All right, reviewing for the progress check. First thing I need to do is rotate this triangle 90 degrees counterclockwise and then translate the image 9 units down. So first, remember what counterclockwise is. That way, against the clock. Okay, the rotations can be really difficult. So the trick here that we learned is to make each individual coordinate and rotate each individual one. So we're going to start with D. How would I normally get to D? I would go 3 right and 5 up. So D normally goes 3 right, 5 up. What about E? E normally goes 2 right and 3 up. F normally goes 6 right and 1 up. 1, 2, 3, 4, 5, 6, and 1 up. Change that 3, make it a little bit nicer. Now, if I want to draw my transformed figure, I need to actually rotate all of these directions. So what does that actually mean? Let's change this. So, if I was going right, 90 degrees counterclockwise going in this direction of right is up. 90 degrees goes up. If I was up and I went 90 degrees counterclockwise, I would go left. So all the rights become up. All the ups become left because I'm following the rule of counterclockwise. So that means to draw D prime instead of 3 up, 3 right, it's going to be 3 up. Instead of 5 up, it's going to be 5 left. Same thing for E prime. E prime, 2 left, 2 right changes to 2 up, 3 up changes to 3 left. And F prime, 6 goes up, 1 goes left. Right? Let's mark all these points. 3 up and 5 left, 3 up, 1, 2, 3, 4, 5. That is your D prime. E is 2 up, 3 left. That is your E prime. Finally, F prime is 6 up and 1 left. F prime. Okay. So rotate a triangle. Instead of pointing downwards, pointing up. Last thing I got to do is translate the image 8 units down. So moving it down here. Take every point, move it down. So D, bring it down 8. 1, 2, 3, 4, 5, 6, 7, 8. D prime prime. E, bring it down 8. 1, 2, 3, 4, 5, 6, 7, 8. And same with F. 1, 2, 3, 4, 5, 6, 7, 8. F prime prime. All right, so it's been rotated, lovely, and translated down. So here's one series of transformations. The next one says reflect it, then translate it. I'm going to reflect it across the x-axis. How do I do that? Well, x-axis is the horizontal axis right here. I'm going to flip it over, meaning it's got the new triangle has to be the same distance below that it is above. So A is 1, 2, 3, 4, 5, 6 spaces above. So I got to go 6 spaces below. That is A prime. B is 3 above, so it goes 3 below. C is 5 above, goes 5 below. 1, 2, 3, 4, 5. C prime. There we go. And then what do I have to do? I need to translate it 7 units to the right. So move everything 7 to the right. One, 2, 3, 4, 5, 6, 7. That's your B double prime. 1, 2, 3, 4, 5, 6, 7. That's your C double prime. 1, 2, 3, 4, 5, 6, 7. A double prime. Connect. Connect. There we go. So it's been flipped over, reflected, and translated to the right. Not too bad. All right, 3. All right, so figure shows lines A, B, C intersecting to form a bunch of angles, and they all lie in the same plane. If B is perpendicular to C, well, that's B, that's C. We know they're perpendicular, even though they don't look, because the figure's not drawn to scale. The figure is not drawn well at all. Because this definitely does not look right to any of us. But we have to assume that's a right angle. Well, if this is perpendicular, which statements produce angle measures of 90? Well, 90 and this did the same thing. So, well, I know for sure 2 is 90. Measure of angle 2 is 90 degrees. What else is 90? Well, if that's 90 and it makes a straight line, doesn't that make these two in total 90 as well? 6 and 1 combined make 90. Well, 5 is also 90. And lastly, the remaining 3 and 4 make 90. Right, A, E, G, and so that I. It's a little more apparent if you decide to erase the A line. Pretend the A line didn't exist. If you actually remove this line, it's a little more obvious that they should be making 90 degrees. So that A line is just kind of a distraction. See? So you can tell for sure that whoever drew this, it wasn't perpendicular. But never assume the figure is drawn to scale. Moving it down. Right, so these are your triangle congruency statements here. A lot of people started to write statements and reasons. You don't really want to do that. That's way too much work. What you need to do first, use the given to label your triangles. Mark the angles and sides that are congruent. Don't jump straight into side, angle, angle, side. You don't know for sure until you actually put it all onto the picture. So, follow our given first. OM bisects LMN. This line here bisects LMN. That means LMN has been cut exactly in half. If it's cut exactly in half, then these two are certainly congruent. LOM is congruent to NOM. How do I know? Because they told me. Let's mark it with 2. You don't want to mark it as the same angle as the first one. So mark it with 2. All right, I have 2 angles that are congruent. Well, they share the same side, right? They are touching. Therefore, this side must be congruent. If it's the same side, like on each triangle, they're congruent. So what is this an example of? Look, I have 2 angles, a side in the middle. That is an angle, side, angle, angle, side, angle on both triangles. If you have angle, side, angle, it says they are congruent. You don't need to write any crazy long proof. We'll be worrying about that later in the year. This is triangle LMO is congruent to triangle NMO. Why? And then you have to label the postulate right here. By the angle, side, angle postulate. You can call it theory, theorem, but postulate's the way we usually find it. So look, I had to label it first, label the triangles, then I can do this. Don't even start the problem, don't even start writing any of this until you label it first. So, given that, we're going to label here HL bisects JK. So HL bisects JK. JK has been cut in half. That means the 2 pieces are congruent. They also told me angle H and angle L are congruent. Mark that. What else? H and L is congruent. And the angle in the center is also congruent. These 2 are congruent. So whenever you have kind of an X shape, the angles formed by the X's are congruent. This is called vertical angles. So the angles that are on opposite sides are congruent. So what is this as an example of? Angle. Well, it's not angle, side, angle. If it was angle, side, angle, the side would need to be there, in the middle of the 2 angles. The angle's not in the middle, it's kind of underneath. This is an example of angle, angle, side. So these triangles are congruent. HIJ is congruent to triangle KIL. A little morbid. By the angle, angle, side postulate. Triangle congruencies aren't the worst. Just make sure you label the triangle. Mark your triangle before you do anything else. Right, this one is coordinate rule. So use the coordinate rule to transform this quadrilateral, identify the transformations that occurred. So I want to actually put these points into coordinate notation. So we're actually needing to do the math. You're going to need to do some adding and subtracting or making things negative. So first thing we're going to do is we're going to identify the first point. So what's the first point at A? That is negative 1, 3. B is 1, 1. C is negative 1, 0. D is negative 3, 2. And I'm going to use all these points and transform them according to this rule. So we're going to transform each point. Transform, 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 transform. Why don't we change colors? So negative 1 minus 5 is a negative 6. 3 changes to negative 3. 1 minus 5 is negative 4. 1 changes to negative 1. Negative 1 minus 5 is negative 6. Negative 0 is just 0. There is no change there. Negative 3 minus 5 is a negative 8. And 2 changes to negative 2. Cool. So I've changed up my points. Now it's time to plot them. So be careful with this. You don't want to lose points just for not plotting it right. 1, 2, 3, 4, 5, 6. 1, 2, 3. So that is your A prime. Mark that here. B is negative 4, 1. 1, 2, 3, 4. Negative 4, negative 1. Sorry. That is my B prime. C is negative 6, 0. That is C prime. D is negative 8, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. That is your D prime. Connect, connect. All right, awesome. I have this this quadrilateral has been switched around. Now, what exactly happened to it? It's definitely flipped over the x-axis. So if it flipped over the x-axis, then it seems to have moved. We can actually tell by the coordinate notation what happened. It reflected over the x-axis, according to this, and I moved 5 to the left. Oh, on your transformations, you're going to write reflection. Sorry about the noise. Reflection over x-axis. And translation left 5 units. All right, awesome. All right, here. All right, here's a whole bunch of angle, all that stuff. Name the postulate or theorem that you would use to prove they're congruent, given the following information. If there isn't enough information, we're going to write none. So, right, this is where you need to label all your triangles. You clearly can't say they're congruent unless you put all this stuff in. So, angle B and angle Y are congruent. Angle A and Z are congruent. Mark those with 2. Finally, BC and YX are congruent. This is an angle, side. So they are congruent by angle, side. So the angle, side postulate. And they're definitely congruent. What about this one? Angle C, angle X. They look right, but don't mark them as right. You're not sure. Angle A and Z are congruent. CA and XZ are congruent. All right, this is an example of angle, side, angle. Right, and these triangles are congruent. AC and ZX. AC is congruent to ZX or XZ, or does it matter? B and Y are congruent. BC is congruent to IX. Oops, I gotta mark that as 2. All right, so this is a example of angle side side. Ooh, bad word. Angle side side. That doesn't exist. There is no angle side side postulate. Nope. There is none. You can't say they're not congruent. It's just there's not enough information. Like maybe they are congruent, but they can give us enough information to really say anything. Right. Next three, ZX. That's a segment. ZX is congruent to AC. XY is congruent to CB. Angle X is congruent to angle C. I got two sides in an angle, but the angles between the sides. This is congruent. It's called the, not the angle side angle, oops. Side angle side postulate. These are most definitely congruent. AB is congruent to ZY. AC is congruent to ZX. CB is congruent to XY. This one's the easiest one. Look, you got three sides that are congruent. This is called the side postulate. All right. Here, AB is congruent to BC. BD bisects angle ABC, which means it cuts the whole big ABC in half. It looks 90, but you need to make sure, don't mark that as 90. It doesn't say anything about that. All right, I have a side and an angle. Well, what's the third side? The side that connects the two. So think about this triangle. I have a side, angle in the middle, side, angle, side, a side, angle in the middle. This is congruent by the side, angle, side postulate. So never assume anything is congruent unless it specifically tells you, or if there's a specific word like bisects, vertical angles, or if they're sharing the same side. And this is most definitely congruent. One last page. This is rotations of lines, gross. So use the graph of this linear function to answer the following questions below. So a lot of you will get confused by this line. Do not touch this line. Do not use this line to create an equation. They already gave us an equation. We don't need to find the equation again. They already gave it to us. So what do I need to do with this line, first of all? I need to rotate the pre-image 90 degrees clockwise. Clockwise is that way. That is terrible. There you go. Rotate it that way, about the origin, and write the equation of the image. So yes, you could do what we did on the front page and rotate every single line. That will take forever. I want you to pay attention actually to these two. Note that this point's on the y-axis and this point's on the x-axis. What we're going to do is rotate these actual points 90 degrees. It's much easier to rotate points if they are on the axes than off the axes. So, if it's 3 up, what is counterclockwise of 3 up? Not counter. Clockwise of 3 up is 3 right. So my new point is there. So this point moves there. Well, this point is 1 to the left. 1 to the left moves 1 up when I rotate it clockwise. So it's going from here to that way. I only got 2 points. Well, what's nice about lines is once you have 2 points, you really have all the rest of them. You just need to follow the same pattern. How do I get from the first to the second point? Down 1, right 3. Down 1, right 3. Plot it again. Down 1, right 3. And then if I want to fill in the other spaces, just do the opposite. Up 1, left 3, up 1, left 3, up 1, left 3, up 1, left 3. Just making sure I did this right. Nope, I did not go left 3. I went left 2. All right, much better. All right, then try your best to draw the line as nice as possible. Rulers will be provided if needed. All right, fantastic. I drew the line, and now I need to create the equation of this image. So the equation we always use, our wonderful friend from Algebra 1, y equals mx plus b. M is the slope, b is the y-intercept. So first I need to do is think about the slope. What is the slope of this equation? To start from the new one, not the original. Do not get confused by the original. Down 1, 3 right. Down 1 means I go -1, right 3, 3. Try to avoid using the word over. Over could mean really anything. B is the y-intercept. When is the new line I drew across the y-axis? At, 1. So 1 above, B is 1. Let's put it all into the equation. Y equals negative 1 over 3, x plus 1. Right? The joys of algebra 1. Next, this one is reflect the pre-image over the line y equals x, and then write the equation. So you need to actually draw with the y equals x line. Don't draw it don't draw it darkly. Dotted lines are pretty good. Yeah, don't draw it too dark, or you may get confused when you're writing the equation. So this is the y equals x line. I need to reflect it across. Reflecting across y equals x is a diagonal reflection. You need to think of it differently. So don't think of up and down. How far is this point away diagonally? So 1, 2, 3.5. So I go 3.5 away. Half, 1, 2, 3. Next, 1, 2.5, half, 1 and 2. 1.5, half, 1. It's half away, so it needs to be half in this direction. Now it's on the other side of the line. Half on the other side, half on this side, half and 1, half and 1, 2.5, with 2.5 this way. Right, just making sure the line looks good. All right, I think it's all right. Connect the line. It has now been properly reflected over y equals x. Now to write the equation. Gross. So I need to find slope and y-intercept again. What is the slope? To get from one point to the other, I go up 1 and 3 to the right. Since I'm going up this time, this one is positive. Y-intercept. When does this graph cross the y-axis? At, look, negative 1. All right, put all of this magic into the equation, and you get y equals 1/3 x minus 1. All right, cool. Is everything out here? Awesome.